This might look familiar, but it's not. This is a different one. This is a Zenith ZDN 400. The one that wouldn't work was a 410, and what I'm curious is to whether this is actually the same machine inside. This is an older one. This is 2004. To my knowledge, this one works. I haven't used it in years. This one was just sitting in a spare room, not hooked up to a TV or anything. I just happened to find it. I thought, gee, it's all dusty. Let's see whether this is the same. Compare some voltages and see whether it's the power supply. Let's see if it's the same first of all as the one I was looking at last night that ran for all those years. Somehow this comes apart. It does look to be the same machine, doesn't it? Geez, it looks to be identical, except for this one's nice and clean inside because it hasn't been running 24 hours a day. So, it's always nice when you have a reference and you can take some voltage measurements. So I think that's what we'll do. We'll take some voltage measurements and I'll waste even more time on this piece of crap that's not worth fixing. But inquiring minds want to know, is it a power supply issue or is it the drive IC? Because I think it boils down to one of the two. It's either the drive IC. See, the drive IC, that's a 5-motor controller. Those 5 motors that it controls. Spindle motor, sled motor, loading motor, and laser, vertical and horizontal shift for tracking. I do believe these machines are absolutely identical inside. So let's measure the voltages. We'll write down the voltages off this one and then we'll check it off this one and see if the voltages are the same. That way we'll know if it's a power supply problem or whether it's something else. And I can plug this one in to verify that it works. Might as well do that before going any further. I'm sure this one works though. It hasn't been used. It hasn't been plugged in probably 20 years. So it might go boom when I plug it in. Or it might not do anything when I plug it in. Oh yeah, it says hello, so it looks like that part's working. We'll just see whether it plays a disc. I don't see any video from this. That might be in a mode that is not compatible. You know what? I bet it's in component mode. It is in component mode. We'll have to get this into composite. So this is sitting in progressive scan. But I can plug into the green output into the video, and that way I can probably get into the menu here and make some changes. Setup. Ah, that'll do it. Okay, let's see here. See if we can figure out how to set this thing up. TV aspect ratio, progressive scan. Let's turn that off. Okay, now I should be able to plug it from the green. I should be able to plug it back into the video out and get a picture. And we do. Excellent. Okay. Even has the same nice, cool splash screen. Okay, get the meter out. I'm going to measure some voltages and see what we got here. We'll write them down. So I'll measure them here at the connector where it goes onto the main board. Just ground out the ground probe on one side and my pen, and we'll write them all down starting with this one. Angle the meter so that I can read it. So we can read it together. So pin 1 is minus 17 volts. The next one over is minus 21, minus 24, 5.2, 5.2, 0, 5.2, 11.9, so 12 volts, 0, 1.7, 1.78, we'll call it, 1.78, 3.3, 0, 8.0. I don't believe I found an 8 volt on the other one, and 0. Okay, now we know what our voltages are on one that works. Let's check the voltages on the one that doesn't work. Okay, so let's start this one. 17.9, which is good. Negative 17.9, which is good. So that one's got a check mark. Minus 21. That's got a check mark. 24, negative 24. Check mark. 5.2, which is good. 5.18, so call it 5.2. Close enough. 0, that's also correct. The next one should be 5.2, which it is. The next one should be 12 volts, which it is. 12.17 on this one. The next one we're expecting to be 0, which it is, which is correct. The next one should be 1.78, and it is. The next one should also be 1.78, which it is. This one should be 3.31, well, 3.3, 3.32, which is correct. Should be a 0 and then an 8 volt and then 0. 0 is correct. Let's check this last one over here, which is also 0. And is this one got 8 volts on it? And it does. So our voltages are the same. Here's our control, and here's this machine. And it's not working. So more than likely it's this IC here that's gone bad. Obviously it's something on this board. It's not the power supply. We know that because our source voltages here are all correct. There's no point in swapping the power supply. We're not going to get any different results. We're going to get exactly the same result. It's going to be more than likely this board here or something on here that's feeding this. Now I could take this one step further. We could check the voltage to the IC itself and see. Maybe there is a circuit protector in here somewhere, or it's gone open on one of these pass-through connectors. I didn't see any circuit protectors when I was staring at it. I didn't see any, but and I checked all the coils and so forth, and I didn't see any of the coils open. But we could check the voltages and just see what voltages are getting to this chip here, and try not to short anything out while I'm in the process of testing. I have a smaller probe here. I have a needle probe for my other meter that might make probing this a little bit easier, but we'll see. Let's just see what the voltages are here. We'll start out at pin 1 and see what voltages I've got here. Basically, I'm going to look to see whether my 8 volts is, because I think we need more than 5 volts. So I'm going to look for one of the higher rails here and just see if I see any, and then we'll check the other one as well and see if I see any. So there's 1.3, 0.7, 0.3, 0.7, 0.7, you see? That'll be ground. One of these is going to have a higher voltage, I'm sure, than 5 volts. .8, 0.7, 0.7, 0.7, 0.5. Oh, the 8 volt supply is there, so this chip has got 8 volts getting to it. It's got 8 volts. 1.3, 1.4, 1.4, 0, 5 volts, there's the 5, 0.7, 0.7, 0.7, 0.7. I bet it's that chip. We'll check the voltage on the other one and just compare them. So the pin that had the 8 volts was this one right here, which was fed off this capacitor right there. Okay, that's the one that had the 8 volt supply right there, and the 5 volt supply was over here off of this one, L204. So that's my source, and I got voltage there. I mean, if I wet my finger and put it around here, these motors should probably go crazy, I would think, because I'm providing them with a bias voltage and nothing's happening. I'm pretty sure it's the chip that's gone. Let's just plug the other one in and just check the same voltages and see. But everything's looking more and more like it's that drive chip. And hey, who knows? I might have one of those in some other broken machine. Might be a project now that we've nailed down where I think the fault is. Pretty sure it's the drive IC. I was pretty sure it was the drive IC last night when I was working on it. And now I can kind of confirm that it is indeed the drive IC. This one, of course, spins. It's on. If I put my finger down here, will it spin? Maybe not. But that is the drive IC. But when I put a wet finger down there, it doesn't do anything. So maybe it requires digital control. But our power on this one here is 8 volts. Yeah, 8 volts right there. And this is the 5 volt supply. And if I just measure the other voltages on these pins just for the hell of it, 1.2, 0.2, 0.1, 0. See, these ones are at 0. The other one was sitting like 0.7, 1.4, 0.1, 1.1, oh, 3.9. 3.9, and those were 0 on the other one. Aha! So these ones had 3.9 volts on it. 3.96, and I think that was 0 on the other one. This one had 1.4. So these two over here, 3.9. That was 0 on the other one. I'm pretty sure it was 0. Let's just put it back up. So these two on the end had 3.9, and on this one they're at 0.7. 0.7. So I wonder where that's fed from. Interesting. So we've lost a voltage. This one here, this is 0.7. This was like 3.9? So I've just been kind of probing around here looking to see where there is a 3.9 source. Maybe a transistor that's open or something. 4.7. Let's just check these transistors here. And I'll check them on the other one as well. I'll check them on the other reference machine. Make sure it's on. Guess I better plug it in. So right here I had 3.9 volts. I just want to check these transistors down here and see whether any of those are feeding 3.9. I'm curious where the 3.9 is coming from. It's 5 volts. It's got to be fed in from somewhere. Can't see where it's going because it goes under the chip. Five volts. 5. To completely waste my time, I'm just going to pop the board out and I'm going to look below there to see where that joins in. I tried measuring continuity and I got no continuity from these pins to anything. Yet on the other one, I get continuity all over the board. Pretty much everywhere I touch, I'm seeing continuity. I'm wondering whether it's a connection underneath the board. Or maybe that chip is just an internal connection in the chip, and the chip itself is burned, which would make sense. But let's pop the board and just take a look under here. I don't think there's anything under here except for some through connections. But we'll find out. I'll just pop out the plugs, undo the laser. I'm going to hang on to this machine anyway because I've got an identical machine. So that works. So that means I've got a laser and a motor and spindle and the whole bit on this one, and power supply. So I'm going to hang on to this unit just for that reason and not recycle it, because I've got a machine that I could use parts to fix. Alright, what's on the other side of this board here? Let's see where this goes. Maybe we'll be lucky it's a connection that's failed. Because it almost looks like it goes right here, doesn't it? It almost looks like this is the chip here. There'd be a connection that goes from there over to there, and then back to the other side of the board. For the hell of it, let's apply 3.8 volts to this chip and just see whether it will make the motors spin. Because this will tell us right once and for all if the motors start to spin when I apply this voltage to these pins of the chip. Then it'll tell us that it's lost a voltage. If not, then it's the chip that's defective. The motors came on because it just wound the laser back. I want the drawer open. Let's just push that laser back all the way again. Watch the laser. Oh, my power came off. Maybe that's why. Maybe that's why the ground came off. It says it's open. No disc. Open. Laser just moved all the way back. Just shut it off. Off. We'll turn this thing on and see if this thing kicks this. It's moving the laser, which it never did before. That moved. What the hell? Let's just throw a disc in this thing. How do I open this thing up without any power? Oh, I gotta pull the tray out. I was gonna throw a disc in it. See if I can make it open. Obviously the chip is doing something when I provide it with external power. Right there. Hello. Open. Will it open? The laser is picking up, the lens is moving. It says no disc on the display. Open, but it's not trying to open. Inquiring minds need to know. I'm going to force a disc into this thing and see what the hell. I can open it up. I forgot how to open this thing up. I guess I got to pull it apart because there's a. I'm not able to push a lever down here. Probably got to pull the front panel off. I'm going to throw a disc in it and see whether it will spin. Giving it external power. Throw that in, and plug it into the screen so I can see if it does anything. And we'll give it 3.7 volts, 3.8 volts. I think it was 3.8, wasn't it? Yeah, it's this chip that's gone, I'm sure. It says it's closed. Open, closed. Turn it off. Turn the power on. Apply it with power. Well, I was trying to spin it. So yeah, I'm pretty sure it's this IC that's bad. That's why it's not working. This IC has failed. And I give it external 3.9 volts, 3.8 volts. It starts to spin the motor. It's not opening and closing it, obviously, but it's trying to read the disc. On. All right, now we know where the fault is on this. that IC, which is kind of what I suspect before. But we were able to prove I can get it to start to spin and get the optical block to move. It won't open and close. Obviously something on this IC has failed, and that's why the voltage is off. That voltage must be internally generated inside the IC, because there's no 3.8 volt sources. There's a 3.3, 3.2, a 3.3 volt, and a 1.78, and a 12, and a 5.2, and an 8 volt supply. And the chip's got both the 8 and the 5 volt. So that 3.8 must be internally generated, but something on that chip's bad. Now we know. Anyway, thanks for watching. This goes into my parts bin because it's got a good power supply and it's got a good pickup, a good traverse. And I got an identical machine that could use it at some point. So thanks for watching.